Okay, here we're going to talk about the division when we deal with operations with radicals. The previous bunch of examples start out with multiplication. And of course, multiplication and division are closely tied. We spoke about that earlier. We'll now deal with how that works. Remember, when you divide, you subtract exponents of the same base. So let us begin. Both of these have square root. So we'll start out by realizing that it's all under one square root. And then we would have 48x to the third over 3xy squared. We're going to simplify the radicand before we even begin. So that's 16. X, and then when we divide, we subtract exponents to the second, and then y to the negative 2. Now, I will put that negative 2 back in the denominator. Again, that's just a habit of mine when I'm gathering my bases to do so. Now, we need to make sure we put this back in place. Understand that 16 is 4 times 4, which is 4 to the second, and we're going to write that as that base. So we end up with 4 to the second, x to the second, y to the negative 2. All of that square root. And now we will put our denominators in. That'll be, our bases are, well, we'll put that up here, 4, 2 over 2, x, 2 over 2, y, negative 2 over 2. Now, please note here, I'm going to rewrite this with y in the bottom as the square root of 4 to the second, x to the second, over y to the second. Same thing, it's just that, I'm sorry, I should put that square root there. Oh, I have an eraser. I'm breaking it up. And making sure we understand that this part, y can be negative now. There is no domain restriction anymore for y. After our simplification right here, we are allowed to use a negative for y, as that will turn it positive, and I'm allowed to take the square root of positive. So when it's all said and done, y will have a square root, an absolute value symbol at the end. All right, continue on. We would have 4 to the first, x to the first, y to the negative 1. And of course, that's an absolute value. So when I write this in simplified form, and remember, when we have the negative, it simply means it's on the wrong side of a rational expression. So this turns out to be 4x over the absolute value of y. And that will be it. Now, there's a note I have for myself here, and I uploaded the pic of these problems done. The answer in the teacher's textbook is inefficient. In fact, they stop short. It's not actually simplified. So what you see here is the extra step that needed to be taken for theirs. You'll see the x to the third and the x to the first, and you'll realize that, hey, I could subtract those, and that's why I have this as my final result. Okay, next. All right. There's only 3 of these in this problem set that explain division, and then 3 for you guys to try. So let's see. We have number 40. The third root of 250 x to the 7th, y to the 3rd. And on the bottom, the third root of 2 x squared y. Sorry, it's hard for me to see my own writing. It's terrible, especially in the dark here. That's why I'm attaching the files, in case my writing gets a little sloppy. Okay, please note that both of them have the same index, and therefore they're all under the third root. We'll start out there. And then we can divide what's happening numerator and denominator. That's all that's occurring here. So we have 250x to the 7th, y to the 3rd, over 2x squared y. All of that is going to be under the cube root because they have the same index. Have they not have the same index? That's for another section. Okay, now we can divide this. That ends up into 125. I'm going to start putting it in base form. 125, x to the 5th, y to the 2nd, all under the third root. Okay, now, just like how this all started, we're looking to write these bases so that 3 goes into it, into the exponent. So I'm going to write this. This is 25 times 5, which is 5 times 5 times 5. So writing this in base form, I would have 5 to the third. And then I'm going to break this 5 up so that 3 goes in. 3 plus 2 is 5. So x to the third, x to the second, y to the second. Of course, 3 is not going into that. Nothing you can do. It'll be in radical form. All of that is under the third root. Okay, now from here, I'm going to put my rational exponents back in. 5, 3 over 3, x 3 over 3, x 2 over 3, y 2 over 3. And just like in the previous videos, the ones that have the numerator less than the denominator will be left in radical form, and the ones we can divide, we will. That's 5 to the first, which is 5, x to the first, which is x. And now I'll put the index back outside. The third root of x squared y squared. Notice we don't even consider absolute values here as the index is odd. One more. Oh, forgot to circle my answer. Put a smiley face. Yay me. All right. Yeah, clean this eraser off somehow. And I am doing this from 2 devices until I get a little bit better at what the hell it is I'm even doing here. So the files and the pictures of the problems will come from my laptop, and the pictures of the worked out problems and the teacher's edition will come from my phone. So there'll be 2 uploads. So please wait until everything's uploaded on a post. It'll come from 2 different sources. You'll see all the files attached and the video attached. All right, thank you very much. Here we go for the last problem in the set. We have 42, the square root of 20ab over the square root of 45, looks like a squared b to the 7th. I believe that's what that is. Excuse me, give me a minute to look in better light. A to the second, b to the third. If I ever develop edit powers, maybe I can do it with a little bit better video here. Okay, all under the square root, so we'll do the same thing. Please understand that what we have here is division. It doesn't divide evenly, but we can reduce the fraction if we divide both of these by 5, which indeed will occur. You can then start to see the 4 and the 9 and the square root coming into play. Here we go. Square root 20ab over 45 a squared b to the third. Okay, now I'm going to write this as bases. This would be, if I divide them both by 5, I would end up with 4 over 9, and then for the variables, a to the negative 1, b to the negative 2. Okay, now these are, oh, it's all under square root. Okay, this can be written as 2 to the second and 3 to the second, which 2 to the second, 3 to the second, and then I'm going to put my denominator of 2 for all of them, 2 over 2, negative 1 over 2, negative 2 over 2. Okay, and now we can just simply calculate these. This turns out to be 2 to the first power over 3 to the first power, and then b to the negative 1, and then a, well, I can put the square root back out actually for this. The square root, we'll have to put it under a. Let me pause here for a minute. I'm going to put these back underneath to make this a little bit more palatable to look at. I'm going to put these back in the denominator here. This will be b and then a. Because I realize I have to take another step here. Square root. Okay, what's going to have to occur here is that this will come out. this will come out because it's b to the second. This will come out, but this will not. So what we end up getting is we have an a in our denominator. It's going to be a square root. We'll have to rationalize our denominator. So easy enough on top. That's why I broke this up so I have a little bit of space to do this here. This will just be 2, the square root of 4. On the bottom, I would simply have 3 for the 9, and I would simply have b, which is what you would get for this, b to the negative 1, b in the denominator. And you would get 3 to the first in the denominator, 2 to the first in the numerator. Same thing here. And a would be in your denominator, but it's a square root. So this is square root of a. Now, the problem is that we're not allowed to have a square root in the denominator. We spoke about that earlier. That was because of the rules of divisibility from like 3rd grade, where when you divide, you move the decimal to the end. Well, as you can't do that here, as there is no decimal, we need another way to make sure there's not a decimal on the inside of the division, which is what's occurring here. So, long story short, rationalize this. We do that by multiplying by the square root of a and multiplying by the square root of a. And this would just be 2 times the square root of a in the numerator. And the denominator would be 3ba. I guess alphabetical order would be standard, I guess. Not that it matters. Not that it matters for alphabetical order, but you might see it that way in the textbook answer key. So, whoop, there it is. Sorry that last one went on a little bit long, and I hope you can backtrack or fast forward through some of the errors. Well, not errors, but the procedure I wanted to show to make sure that you understood why that occurred as the result. Thanks very much. Talk to you later.